This is video number 2 for sections 1.5 and 1.6, finding the equation of a line using the point slope formula. So essentially what you have in this video is a second way to find the equation of a line. I'm going to say a second optional way because if you like the other method, if you like the y equals mx plus b temporary plug-in method, you are welcome to just use that. You are not required to use this point slope formula unless you want to. Why am I teaching it then? Well, because I know there are always some students who really prefer this second way instead of the y equals mx plus b way, and so I want to make sure and help those students. Okay, the first thing I need to do is I need to show you where this formula comes from. It is a formula. Imagine I have some line in the xy plane, and I'm going to pick on some specific point on that line, which I'm going to call x1 comma y1. So that stands for a specific point. And then I'm going to mark some other random spot, and that stands for all the other points on the line. So x comma y could be here, could be down here. This is just generic. This one is a specific point. Well, the thing is, no matter where I mark that generic point, the slope between those 2 points is always the same. So I could use my little slope formula. Second y minus first y. Second x minus first x. And then if I clear the fractions, so let's see, LCD would be this x minus x1 thing. If I multiply both sides by x minus x1, what I end up with is called the point slope formula. Here, these things cancel. Let me also rewrite it in the other direction. So I'm going to put the y stuff on the left, y minus y1, and then the other stuff on the right. So I have the m, and I also have the x minus x1. So this thing right here that I just wrote down is called the point slope formula. If you want to use this method, then you need to memorize this formula. Okay, so that's maybe one of the downsides. It is an extra thing to memorize. You say, well, why would anybody want to use it then? Well, I think some people like it because it is really a formula. In other words, all you do to use it is you plug in the slope, you plug in the specific point. Remember, x1 and y1 stood for the specific point. And after you plug those 3 things in, you have the equation of the line. Now, you still have to clean it up. You have to put it in the nice format. But this is a little bit more straightforward, I suppose, as a method. Let me demonstrate it for you on this example problem. It'll work on any of them. You know, you could go back to the one from the last video and try this out. It'll work just the same. Here is this example problem. It says find the equation of the line, and then we're given 2 things about it. It's perpendicular to this other line, y equals 3x plus 7, and it passes through the point negative 1 comma 2. So we know a couple of things. Our job is to find the equation of the line. Again, the y equals mx plus b method that we used earlier, that would be fine. I'm just showing you an alternate method. It still boils down to 2 things. I mean, at some point I'm going to have to figure out the slope, and at some point I'm going to have to figure out the y-intercept. This is just a different way of doing it. Okay, as far as the slope, let's see. So my line is perpendicular to this other line. Why would I care about this other line? Only for one reason, right? I can see clearly that the slope of this other line is 3. So that means my slope, my m for my line, is going to be the opposite reciprocal of 3, which would be negative 1 over 3, negative 1/3. And that's pretty much all I needed to get from that information. So my slope is negative 1/3. What else do I know? I know that my line goes through this point. Of course, this is not the y-intercept. There's no 0 comma something. Otherwise, this would be a super simple problem. It's just some other point on the line. Well, if you're going to use the point slope formula, then this is your specific point. You have to pick a point on the line. This is the only one I know, and call that your x1 and your y1. That's all you need in order to use the point slope formula. Now you take the formula, you copy it down. You are not filling in anything for x and y. This x and y are the x and y that are going to be there in the final answer. Okay, this one does not have that temporary plug-in idea. It is a different method. You just plug in those three specific numbers. This is a number, this is a number, this is a number. So let's see, my y1 is 2, so y minus 2 equals, then comes the m, then you open a parentheses, and it's x minus the x1. Let's see, the x1 is negative 1. Be careful, several negative signs in there. Well, that's the equation of the line. I mean, it really is that simple. Again, most of the work now comes in because I can't leave the answer like this. I'm expected to clean it up. The final answer still needs to look like y equals mx plus b. So what would I do? Well, I think I would plus out those two minus signs, making that x plus 1. And then parentheses. I don't have any parentheses in my final answers to these problems, so I should distribute that negative 1/3 to deal with that. Negative 1/3 times x, negative 1/3 x, negative 1/3 times 1 would be minus 1/3. You probably have to be a little bit more comfortable in dealing with the fractions when you use the point slope formula. I hope you're looking at this realizing we're just about there. I mean, it's almost in the right format, the y equals mx plus b format. The only reason it isn't is because of this minus 2. I can easily fix that by adding 2 to both sides. Now, if you're looking at this thinking, I don't know, now I'm going to have to deal with these fractions, I suppose I could have cleared the fractions at this step, right? I could have multiplied everybody by 3, which is the LCD. I find that in these point slope ones, though, that gets pretty cumbersome. It just creates a lot of extra work later. So I would probably only use the point slope formula if I were you, if you're comfortable dealing with the fractions. It's not that bad. Here, this cancels. And then maybe I would go off to the side. I just need to work this little problem out. Negative 1/3 plus 2. All right, 2 is 2 over 1. I need to get a common denominator. It looks like it would be 3, so multiply top and bottom of this by 3 to make it negative 1/3 plus 6/3, which of course comes out, negative 1 plus 6 is 5, so this would be 5/3. So it looks like I'm ending up with a final answer here, y equals negative 1/3 x plus 5/3. Remember, I said at the beginning that somehow we were going to end up having to figure out the slope and the y-intercept. We found the slope really early on. We didn't find the y-intercept until just now at the very, very end. In any case, this is using the point slope formula. If you want to try it out and see if it's working for you, you're welcome to do that. My suggestion in general with these two methods is that you pick one of them and just use it every time. So you might want to try each one out, but whichever one you end up liking the best, just stick with that. And you can use on quizzes and tests. I'm never going to specify which of the two methods you have to use. You're welcome to use either one. Let's go to the calculator and do a little bit of checking with this problem. And this, of course, is optional. I just want to show you, what you have available to you if you want to do some checking. Let me go to the y equals. I'll put in our answer, which was negative 1/3 x plus 5/3. And I have two things to check. I'll go to Zoom 6 and get the picture. The original problem, one of the things it said was that I was looking for a line that goes through the point negative 1, 2. Well, we know how to check that. That's the trace button. Type in that negative 1, hit enter, and make sure it really goes to that point. Sure enough, negative 1, 2. So that worked. The other part is maybe a little bit trickier to check. I was supposed to check that my line came out perpendicular to this other line, and the other line was y equals 3x plus 7 if you check the handout. So what I could do, just to try to verify this visually, I could add that in. I could go back to the graph, and I'm just trying to see, well, do these lines look perpendicular? And I would say at the moment, not really. It doesn't really look like these are right angles here. Well, your calculator is misleading you a little bit. Notice your calculator window is in the shape of a rectangle, not a square. And so because of that, the pictures you see on here are actually slightly skewed. There is a setting that adjusts for that in the zoom menu. It is choice 5, Z square. And if you choose that, the calculator will readjust the window to draw it so that it looks the way it would if you were doing it on a sheet of graph paper. And I think now you can see, oh yeah, this is definitely 4 right angles here. These two lines are perpendicular. And so our problem checks out, and that gives me confidence that we have the right answer. As I said in the last video, please make sure you are practicing this stuff a lot. You are going to need these skills in this chapter as well as in the chapters to come.